Hey guys, welcome to another video. So today, final installment of the integration with recurrence topic. I promised you a few more harder questions in the topic. So today I've got two prepared. They're going to take a while, right? And you'll see with the number of marks that they've been allocated with, I mean, it makes sense. So the first one from the HSC 2020, it's 11 marks, right? More than 10% or 11% to be exact of the test is one, I guess, concept, and that's recurrence, integration with recurrence. So if you haven't already done so, please hit up the previous lessons on integration with recurrence just to get the framework and the context, right, and the way we approach this. Today, let's do some hard questions, just two of them. Not sure how long this video will take. Maybe it's short, maybe it's long, but I only got two questions. So, well, let's make a move on, right? So, HSC 2020, 11 marks. So, it's almost, these questions are two-parter. Some of it is your classic integration with the recurrence. Some of it, you just got to use the recurrence formula, a bit of combinatorics where you factorize factorials, etc. So let's get this show on the road. So there's my recurrence statement, right? Off the bat, it basically says in equals to sine power 2n plus 1 of double angle d theta n is okay, cool. So I mean, just looking at it, it's not pretty, is it? Like, but the fact that it's sine, right? We're gonna need. Remember, I said to you, Lie8 fails when there's really only just trig in this case, but we're smarter than that, right? We know that with sine, we try to extract out one value of sine and let that be dv because I can integrate that, and then let sine 2n in this case be the du or be the u, right? So I can differentiate that. So let's quickly have a glance of on what I need to prove. The first one's integration by with recurrence formula, pretty classic. And then it feels like I'm gonna, once I've derived that formula, sub in a few values of in to get another expression. Well, 3 marks, that might be a bit intense. And then it looks like I've got another formula given, right, that I have to prove, right? And I'm suspecting that I need to strategically target a substitution for x to make it link in with in, because it looks broadly the same sort of thing. In fact, it looks very similar, in fact. So maybe a strategic sort of substitution there and then some sort of cleanup thereafter. All right. You know what? That's enough of a preamble. Let's begin. So part 1, all right? We have in equal to 0 pi on 2 sine 2n plus 1 double theta d theta. Now, like I said, because it's just sine, feels like if you've already seen my trig video, it sort of says let u equal to, so I'll strip this out into sine times 2n, so it'll be sine 2n 2 theta, right? And then let dv equal to one of the sines, right? Sine double angle. Yeah. In which case, when I go du, let's see, du, bring down the 2n, all right? This is chain rule. So then knock off one of the powers, sine 2n minus 1, 2 theta, all right? And then multiply that by derivative of sine 2n. Geez, this is hurting my brain a bit. So sine 2n, bring out the 2, sine 2 theta. No, that's not right, cos 2 theta, right? Cos. Can I just write 2 theta? I'm just going to get rid of these brackets, right? It's just, it's not very obvious once I start writing these brackets of what I want is just, let's just write 2 theta. Yeah, I think that's right. Nothing wow about that. And then over here, v, guys, when I integrate sine double angle, I get sine integrates negative, right? The acronym, so that becomes negative cos 2 theta on 2. Now, let me quickly glance. I don't think I've done anything too fancy there. Cool. Let's use by parts. So therefore, in equals to. So this question, I mean, if you've seen the trig questions I've done in the past, it's similar, it's just uglier, right? It's got double angles, it's got 2n plus 1, but conceptually, same thing. So UV with the limits. I'm hoping that when I sub the limits in, guys, it goes to 0, because I think it's a pretty clean, yeah, it's pretty clean integration by with the recurrence statement that I'm trying to prove. So UV, so sine, let's play the game. I think when you sub in pi on 2 and 0, it goes away. So minus cos double angle as well. Sorry, I said I'd get rid of the brackets for double angle. I didn't. Just for that one, doesn't matter. Yeah, so UV and then minus. Now this guy times this guy. What do I have? That minus there turns it into plus. That 2 and that 2 cancels out. So there's a 2n there outside of 0 pi on 2. Now let's see. I've got, what do I have here? I've got 1, 2, 3 things multiplied, right? So cos squared, good, because I think it'll make me, so it's like right now it's sine 2n minus 1 double angle multiplied by cos squared double angle d theta. Feels like I'm going to use now the identity for this guy of 1 minus sine squared double angle to get my my in back in. So let me just make sure that's right. Yeah, so all right, subbing in these limits here into here, I suspect, guys, if you allow me, this question's 11 marks long, so bit of a shortcut. So if I sine double angle, sorry, pi on 2 into sine, 2 times pi on 2 is pi, sine pi is 0. Sub in 0, 0. So that guy, that's gone, right? Perfect. So therefore, in equals to, now this guy here, there's a 2n in front. The moment I sub this in, if I expand that using rainbows, I get sine 2n minus 1 theta. Yeah. Minus, guys, sine 2n minus 1 times another 2. That's sine 2n plus 1 theta, d theta. Now, let's just really gather what this means. So I use blue here. So I know that this guy here is looking like my original. Sorry, I didn't get the double angle in there. So that's 2 theta. That guy's looking like my original. So this guy here is in. All right. This guy here, now just to be clear, so if I subbed, so for 2n plus 1, if I replaced n with n minus 1, right? So 1 down, that's like 2n minus 1 plus 1, which is 2n minus 1, right? That's this guy. So just because it says 2n minus 1 in the power, it actually is when n is replaced with n minus 1. So this guy is n minus 1. Yeah, that's really what I wanted to include, right? So once I do that strategically, right, I know that this is going to go down a path of, this is in minus 1 minus in, and where I think on easy straight, let me just have a quick glance what I need to prove. So when I expand that 2n plus 1, perfect. Then okay. So right now, rainbow that, expand that, and I've got in equals to 2n in minus 1 minus 2n in. Bring that guy over and factorize. So it becomes 2n plus 1 equals to 2n in minus 1, and divide it over for my recurrence statement, right? 2n, how do I express it just as a fraction, right? 2n plus 1 in minus 1. Guys, 3 marks, HSC, not bad, right? So that was, I mean, it's ugly, but it's very classical, right? Classical in terms of, it's just a trig one, and trig ones are common, I told you, right? And it's probably the harder type of recurrence question. So now I've run out of space quite quickly. So let me just, I made a copy of the slides. So I'm going to make a few more because I'm pretty sure with 4 parts, 11 marks, I'm going to need more space. All right, guys. Hopefully that's okay for part 1. Let's dive into part 2. So it feels like for part 2, they want me to basically use the recurrence statement above and sub in a few iterations of in, or actually sub in all of them to get that statement. So let's explore. So part 2, yeah, I've proven from part 1 that in equals to 2n times 2n plus 1 of in minus 1. Yeah, so let's sub in a few iterations, right? And by that I mean, now, if in equals to this, then in minus 1 would equal to, right? Let's sub it in where if I replace all the n's here with n minus 1, so that guy would be 2 times n minus 1, and the bottom there would be 2 times n minus 1 plus 1, so it's always 2n minus 1, right? And then this guy would be 1 lower, so that's n minus 2, right? So just to be clear, that pink box there is equal to that one, right? Let's go one more, all right? Just to get pattern, yeah, get pattern. 2n plus 1 times 2. Maybe I'll expand it, right? If I go 2n minus 2 right now, right, over, because then you can easily ascertain pattern, right? So 2n minus 1. You can see that this one is always 1 smaller, right? So then times, if I sub in n minus 2, I reckon it'll get 2n minus 4, right? 2n minus 3, right? Of n minus 3. And so on and so forth, right? So that there would be, sorry, if I was to color code it, that there is that guy, right? And so on and so forth. So sooner or later, you're going to hit a pattern, right, where it's like 2n. So maybe I'll put all these into one fraction, 2n minus 2, 2n minus 4, dot, 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 dot. Now, where does that go to? What's the lowest number it can go to? Probably I0, yeah, where n equals to 0, cool. So n can go down to 0 where, what's my second last number? So let's go when n equals to 1. N equals to 1, that's 2, right? The top number is 2, the bottom number is 3, and then that's I0. So dot, dot, dot there, and the numbers over here will be 2n plus 1, 2n minus 1, 2n minus 3, dot, 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 dot. The last number is 3, right? And maybe I'll put in, to be exact, right? It's a times, right? And then it's I0, right? Now, it's sort of taking shape. I can sort of, if I factorize all 2's out the top, I get n minus 1 all the way down to 1. I get the factorial. I can see the factorial, right? And if I factorize all n's out, it'll be 2 to the power of n. I can sort of see that, but there's 2 to the power there, and there's like factorial squared, right? That's important. Now, at this point, I want to get rid of the I0 first because there's nothing I here. So what I'm going to do, guys, pull this I0 off to the side. Let's quickly put a bullet in that. Right, I0 equals 2. So from 0 to pi on 2, sub in 0 here, power, that's gone. So that's just 1 d theta. Is that right? 1 d theta? No. No, because when n is 0, that's sine. My bad. So that's like sine double angle, right? Yeah, because when n is 0, perfect. Sine integrates negative, so negative cos 2 pi on 2. So limits of pi on 2. I'm hoping these numbers are nice, right? Let's see, please. So I'll leave the negative half there. Cos pi minus cos 0. Cos pi is negative 1, isn't it? Negative 1. That's like negative 1 minus 1. Negative 2. Oh, it's 1. Yeah. So I'm going to put 1 back into there, which is 1. Yeah. Cool. So then actually, so the I0 does nothing. So I'm hoping that this guy here and this guy here gives me exactly what this is. So now, big brain strats, right? As my 11-year-old son would say, this is what you do. If you look at the bottom, right, these are like odd numbers, aren't they? Yeah, it's like 2 plus 1, 2 down, minus 1. These are odd numbers. So to get the full factorial of the bottom, right, because the full factorial looks like what, 2n plus 1, right? And then times 2n, and then 2n minus 1, and then 2n minus 2, and 2n minus 3, right? So it looks like what I currently have is this guy, and this guy, and I'm missing that and that. So I'm gonna multiply top and bottom of this fraction by the missing guys. And it's no coincidence that the missing guys are exactly what this is. So that's why in the thing I have to prove here, I've got one lot of factorial, I've got one lot of 2 to the power of n, but if I multiply top and bottom by that again, on top, I'm going to get squared. On the bottom, I'm going to get the full factorial. So I'll show you what I'm talking about. Right, I'll show you what I'm talking about. So right now, I have on top one lot of 2n minus 2 that goes all the way down to 2, right? And right now, it's sitting on 2n plus 1, 2n minus 1, all the way down to 3. Guys, I'm going to multiply top and bottom by the same thing as this guy, right? I'm going to multiply top and bottom by 2n minus 2, all the way down to 2, top and bottom, the even guys, right? The even numbers, because the bottom already has the odds, right? 2n minus 2, dot, 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 times 2, right? Same thing. Now, what that means is that on the bottom, all the evens sort of slot inside. Yeah, it sort of slots neatly inside where all the odds are. So it becomes like 2n. Sorry, I'm using colors here just to illustrate point. And then 2n minus 2. And then 2n minus 3, blah, 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 all the way down to times 3 and times 2, right? Nice. It completes or helps me complete the factorial. And on top, if I now, in both brackets, factorize 2 out, right? It'll be like 2 to the power of n, because there's n terms, right? Squared, because there's 2 of them, right? So squared, and then multiply that by n factorial squared, right? Because that's what it is, right? If I factorize 2 from each point, maybe I'll do it in 2 steps. Maybe I'll go and factorize, it'll be n times n minus 1, n minus 2, and the last 2 factorizes to 1, right? So there I have it, right? Because 2 to the power of n to the power of 2, that's 2 to the power of 2n. This guy, oh, there's 2 of them squared, so that's times. Did I put times? Probably not. No times, so you just put a bracket. So let's just go bracket n factorial squared, and on the bottom 2n plus 1 factorial. Boom. 3 marks. Wow, nice. Does that make sense? So I just needed to craft it from subbing in a few iterations, get it down to I0, find I0, get rid of it in this case to 1, and then see how I can solve it. It looks like it was missing the even guys, so times that by the orange, get it done. Yeah, guys. Next question, right? You can see why these are 11 marks now. It's a 3-hour exam, 10% of a 3-hour exam. 3 hours is 180 minutes, 10% is 18 minutes. So this is a 20-minute question, right? So sort of warrants the time that we're spending here already, right? So let's go for the next one. Now, for the next one, I have this, right? Let that happen. Guys, how do I link that with what I had before? Feels like I'm going to strategically sub, right? So using part 2, show that. Okay, cool. So for part 3, the first question is if Jn equals to the integral of 0 to 1, xn 1 minus xn, right? dx. All right. I need to strategically substitute something into x to make it work. Now, let's see. What can I do, right? Why don't I? And I'm thinking, right? I've got 2 choices, really. I'm thinking maybe let x equal to sine theta. Now, I was thinking sine 2 theta, but I think when you sub in sine theta, let's see, this guy becomes sine n theta. Now, do I want 2 theta then? Maybe I do want 2 theta. Maybe don't. Well, let's go here. Now, the reason why sine, or maybe not even sine theta, right? Maybe I want sine squared. And the reason is because I want this guy to basically collapse. Right? 1 minus sine theta doesn't get me anywhere. 1 minus sine squared becomes cos squared, right? And then cos squared feels like I can use some sort of identity or I know some sort of identity or maybe integration. Let's explore that, right? So strategically sub in x equals that. Let's see where that takes us. Therefore, Jn equals 2. Now, when I sub, I'm going to replace the limits as well, right? Now, I'm hoping that when I do replace the limits, if it gets me to 0 and 2 and pi and 2, that gives me a lot of comfort, right? So when x equals 0, theta is 0, sine, yep, definitely 0. So when x equals to 1, sine squared 1, perfect, right? Perfect. Pi and 2, great. So my limits are re-established, right? So let me move this down. Yeah, because I want the limits to be the same as the parts above, right? That's really telling me that I'm on the right track. Now, if I sub sine squared into here, right? I think sine squared works. Let's see. The power of n, because when I expand that, sine squared n, that's 2 to the power of n, right? That's almost there, right? But it's a double angle that's worrying me. Hopefully, right, things will sort itself out when I get the cos squared in, because cos times sine, I can somehow establish sine double angle in there, right? Let's see. So that's 1 minus sine squared. Let's just go cos squared to the power of n d. Oh, I didn't. I'm going to multiply. I'm going to find my using almost u sub methodology. Dx equals 2, because I'm replacing dx as well, right? Dx equals to bring down the 2 sine theta cos theta, right? So I need that in. So multiply that by 2 sine theta cos theta d theta, right? Almost like u sub. Now, check this out. When I expand that, that's 2 to the power of n, right? That's 2 to the power of n. That's 2 to the power of n. So I can actually combine that, right? I can actually combine that. And there's one more, right? So sine to the power of n plus 1, cos to the power of n plus 1. So when I actually do this, right? I'll take that 2 outside for now. Yeah. And then I can actually go, well, that's like sine theta, cos theta, brackets around this. Now I'll leave a little bit of space because I'm going to go big brain. And that's 2n plus 1, right? Guys, you should be very comfortable at going, well, I want a 2 in here, right? To make that double angle. That's how they get the sine 2 theta in there. By putting a 2 in there, now maybe what I'll do is I will give myself a bit of space so I can do this better. So let me ungroup that. And I will give myself a bit of space so I can show you exactly what I'm going to do. So I'm going to introduce a 2 to make the double angle work, right? Because together that is sine double angle. And then at the same time, introduce a half to cancel it out. I'm going to take that half outside and leave the 2 theta inside, 2 sine theta inside. So when I take that 1 on 2 to the power of n plus 2, there's already a 2 there. So when I take it all outside, it becomes 1 on 2 to the power of n, right? Does that make sense? Yeah, because that's 1 on 2 to the power of 2n plus 1. When I take it out, there's a 2 there to cancel out one of them. And then what's left inside? Sine double angle. Sorry, sine double angle to the power of that, which we all know that is in, right? That there is in, which we have established in part 2, because the question is asking me to use part 2 to sub into there, right? Which then gets me my answer, hopefully. Let's have a look. Right, equals to 1 on 2 to the power of n times 2 to the power of 2n. Yeah, 2 to the power of 2n, that's like 2 to the power of n squared, right? Times n factorial squared over n, 2n plus 1 factorial. That's nice because then I will cancel out this guy with this guy, and that's exactly what they want. Is it? That's not what they want. Oh, duh. I've done a mistake there, so let me fix that. I thought I'd outsmarted myself. Sorry, I thought I got it, but I outsmarted myself. So I'm going to replace that back with the original 2n, right? And that's 2n as well. Now it goes, right? That's fully gone, because then that and that is equivalent. Great. And therefore, Jn equals to n factorial squared over 2n plus 1 factorial. So, strategic substitution. Now, you could have tried sine squared 2 theta. I don't think that would get you it, because then you would double angle 2 theta to get 4 theta, and then you would have realized you would have been a bit of a mess, right? Guys, once you get that, now, final 2 marks, right? The final 2 marks, unfortunately for you, to do it, it's a bit of a understanding, right, of what the original question is, so the Jn is, right? So let's go there, part 4, right? Part 4, between 0 and 1, yeah, of x. Now, what I'm going to do, so this is Jn, right? And I know that Jn is that, so maybe I'll just combine 1 minus x to the power of n, if that's okay, dx, right? Now, I know, right, because this is a less than here. Now, there's so many ways to attack this question, right? In this question specifically, what they've done is basically they've looked at this as a quadratic, right? That's a parabola, isn't it? That parabola looks like from 0 to 1, right? Now, I know that this parabola has a maximum, right? What's that? When that's a half, if I sub in half into there, half times a half, that's a quarter, right? So the parabola, this green expression here, right, has to be smaller than, so x, 1 minus x is less than or equal to a quarter, right? That's a maximum value you can take. So what they've done is basically said, this function here has to be less than or equal to 0 to 1, and they replace this parabola expression with 1 on 4 to the power of n dx. Now, how do you know this? Once again, right? This is a HSC. This is one of the hardest questions in there. Just through a number of, I guess, hard to say, right? And the fact that it's less than or equal to sort of tells you something to do with that function itself. Now, some of you might think it's area under the curve. Some of you might use calculus in other ways. In this one, it's simply just maximum turning point, right? Because if that's the case, guys, if I take this guy, right, that's just a constant, right? It's a constant. So if I hack on the x, so it's a constant to the power of that. Let me see. So 1 on 4 to the power of n, actually, it's not a constant, is it? So if it's a constant, so let me do this, right? Let me see. It's actually harder than I thought it was. So to the power of 2n dx. Is that right? Yep. Yep. Okay. Power of 2n now. Oh no, this is a constant n. Okay. What am I doing? For a second, I thought it was x. I was like, thinking about the a to the power of x. No, that's just a constant, right? N and x. So that's just something one. I think you get. Oh, sorry, that should be a minus there. I wouldn't even bring up z. Sorry, I don't even need to integrate that. That's just constant, right? So then that just becomes 1 on 2 to power of n, yeah, x with the limits of 1 and 0. So then it would just be 1 on 2 to the power of 2n. Great. So therefore, this is saying that Jn, which I've in part 3, let's use part 3's expression now. This guy, and sub that into this side, right? Jn, so n factorial squared all over 2n plus 1 factorial is now less than or equal to 1 on 2 to the power of 2n. I think I'm almost there, right? So what they've done is they've crossed this guy upstairs. Is that right? And then they've put this guy into the factorial, and that's it. So cross multiply that, everything's positive, so I can. So I got 2, maybe I'll go 2n squared times n factorial squared is less than or equal to 2n plus 1 factorial, and then combine the squares on the left. I got it right. So therefore, 2 to the power of n factorial squared less than or equal to 2n plus 1. Guys, that's it. Yeah. Whew, that is 11 marks, right? So took us about 20 minutes to get there. Feels about right, guys. That's a hard question. Yeah, let's do one more just to close off this part of the topic. One more from North Sydney boys, right? The next question is a classic question. I like it because it's hard because of part 4, right? Everything leading up to there was fine, right? Classical 5 marker, not too bad. And then part 4, this odd and even thing, it just warrants a little bit of thought, right? So now let's see, part 1, right? So let me once again establish that this is my original IN. So it looks like it's telling me to prove that. Okay, that's just by parts, nothing hard there. And then recurrence, right? So that recurrence statement there, not sure whether that's hard or not. Don't think there's only 2 marks. They make me want to, then they go, can you please find me 2 values, right? And then this guy, wow, okay, let's go there. So part 1. Part 1 is just by parts. So if it's the integral of ln 1 plus x dx, right? If I let u equal to y8, so ln 1 plus x, and let v equal to 1 dx, sorry, dv, I got du equal to 1 on 1 plus x dx. I got v equals x, right? Therefore, this guy equals to uv. Let me just make sure. Okay, looks a bit different. Plus, I think it's okay actually. So minus this guy times this guy. It's minus that times that. Dx. Now to do this, you strategically substitute a 1 plus and a minus, right? And you break up that fraction. Give me x ln x, ln 1 plus x minus that integral of 1, because when I split it, it's 1 minus 1 on 1 plus x dx. And I go again. This is 1 mark, man. I guess it's not hard, but it's a lot of work for 1 mark. X plus, that's ln. Plus c now, and then all they've done, let me just check that minus x, perfect, is they factorized this guy and this guy to, is it 1 plus x? 1 plus x, right? Because it's x and 1, so they basically combine those two to 1 plus x ln 1 plus x minus x plus c. Done. 1 mark. Okay. Next question. So I'm assuming then in the next one, I'm going to let dv equal to ln 1 plus x because they've made me integrate that in part 1, and then I'll use it in part 2 as part of the recurrence. Hopefully, otherwise it'd be a waste of time, right? Let's see, next question. So show that in, okay, cool. So in 0, 1 limits x, yeah, there it is, ln 1 plus x dx. Yeah, so normally y8 tells me to let u equal to this, but then why did they tell me to integrate this, right? It's to give me the ability to set this guy as dv. Can you see that? Because then I'll integrate that, and I already did that, or I've already done that in part 1, right? And then let this guy be u. So that is the key, right? So I'm going to let u equal to x to the power of n, and let dv in this case be ln 1 plus x dx because I've already integrated that, right? So I know that this guy becomes, so du becomes nx minus 1 dx, right? That's pretty straightforward. This side here, if I integrated that, I use part 1 and I got 1 plus x ln 1 plus x minus x, right? That's hopefully, right? Let me just quickly check. Has to be, right? Like I'm pretty confident that's right. So therefore, in equals to limits u times v. Okay, should be 0 because doesn't matter. So if I go xn multiplied by this guy, right? So 1 plus x ln 1 plus x, or maybe not. Let's look. Close bracket 1 and 0 minus this guy times this guy. Wow, that's hectic. Okay, shouldn't be that bad, I think. So take out the end, 0, 1, x n minus 1 multiplied by 1 plus x ln plus x minus x dx. That worries me a bit, maybe. Oh, actually, no. It's all good. It's all good. So if I sub in 1, 2, ln 2 minus 1. So if I sub in 1, I still get like 2 ln 2 minus 1. And if I sub in 0, whole thing 0. So it is just 2 ln 2 minus 1, right? That's all this bit, and minus n. Now, guys, are you okay if I take this guy and I multiply it with this guy? That looks exactly the same as my, oh, no, there's an x there. Oh, no. Okay. This is what I'm going to do. So obviously, there's this term, right? Obviously. When I take this guy times this guy, there's another bracket. So I'm going to be multiplying that with that and that with that first. So they get like, let's see what that takes. 0, 1. So that times 1 would be x n minus 1 ln 1 plus x. And then plus that times x would be x n ln 1 plus x. And then minus x n, right? dx. That's good because that looks like my original, but with a power of n minus 1. So that must be I n minus 1. This guy looks exactly like my original. That's I n. And this guy, well, let me simplify it. The other guy I'll integrate. So that's 2 ln 2 minus 1 minus, now I'll expand it, right? I'll take that n times that. And then minus n times that. And minus so plus integral of 0, 1 xn dx, which I think does that give me a fraction? Yeah, I think so. And that's in right now, right? So let me just quickly do this off to the side, right? So that is xn plus 1 plus 1 limits of 1 and 0. So 1, 0. Okay, it's 1 on n plus 1. So let's do a number of things. I think I have to, well, actually the question, if you look at it, bring this guy together with this guy and factorize n plus 1, right? That's all they want me to do. And then with 2, there's a minus 1. Oh, wait, where's my minus 1? Why is there a minus 1 there? Does my minus 1 go away? I think I might be forgetting something. Let's see. Plus 1, so when I sub in 0, so it's 1 and 0. Why doesn't my 1 go away? Oh, you know why? So when I sub in, I forgot to do this, guys. I did this bit incomplete. See that there? When I sub in 1, I got that perfect. But also when I sub in 0, oh no, when I sub in 0, it should be 0. What am I missing here? What am I missing? Oh, I know what what am I missing there? What am I missing there? Oh, no, sorry, my bad. this thing here had an n in front. So that should be n in front, and that should be n. Yes, because then when I split this guy, right? When I split this guy by plussing 1 and minusing 1, wow. How many marks? 2 marks. This question, it's like a, so that becomes 1 minus 1 on n plus 1. And that 1 there, and that plus, yeah, perfect. We'll cancel out. So let's bring that over. It's 2 marks. Right, so yeah, I mean, I like this question because it's hard, but so just to be clear, that 1, get the third color, that 1 and that 1 goes away now, right? And I get 2 ln 2 minus 1 on n plus 1, and this guy, right, minus n minus 1, which is, I think, yeah, perfect, exactly what I want. Damn, that is heavy, right? But there you go. That's the recurrence part. So most questions, that's probably the hardest part. I think for this one, the last part is a little bit harder, but let's persevere. Now, part 3, they want me to find 3 elements. So I'll start with when n equals to 3, right? Because then that becomes 4 in3 equals to 2 ln 2 minus 1 on 4 minus 3 in2, right? Let's go there. So then 3 in2 equals to 2 ln 2 minus 1 on 3 minus 2 I1. Now, can I do I1? Feels like I should do 2I1. No, let's just keep going. 2I1 equals to 2 ln 2 minus 1 on 2. So this is n equals to 2, this n equals to 1. I0 and goes off to the side. Let's do I0. I0 equals to, now, 1, 0, so it's just ln. So that's just integral of 0, 1 ln 1 plus x dx, which we've already integrated, right, to be 1 plus x ln x, 1 plus x minus x, 1, 0, what's that, guys? And that's 1, feels like it's 2n ln 2 minus 1, and when that's 0, ln 0 is 0, just that. So I need to sub that retrospectively back. Yeah, sub that back in. I don't have any more vertical space, so I'm just gonna, you know what? Let's not try to squeeze. I'll move this into the next page. Okay. Sub it in. So therefore 2I1 equals to 2 ln 2s minus a half. Half? Is that right? Let me just check that. Sorry, bear with me. I have a feeling 2 and 1 that oh, it's not multiplicative, it's minusing. So just be careful there. I did a silly mistake. Yeah, because I was like, I recall it kept on minusing, right? So I recall that this becomes 2 ln 2 minus 1. Guys, I recall this action happened, right? Every time you sort of sub it in, the ln sort of goes away for a while. So that becomes what? Minus half plus 1, that becomes half, all right? A half. Now, can I ask a favor, actually? I want to show you something, right? So before I write a half, so what is that? That becomes 1 minus a half, right? Which we know is a half, yeah? Which we know is a half. And I'm going to sub a half back in. But now, the reason why I want to show you something is, let's use a different color. So that's a half. You can sub in a half, right? So I want this guy, right, subbed in. I'm going to sub in this guy. because it's actually leading me on to the next part, right? Strategically. So sub that in. Let's see what you get. You get, therefore, 3i2 equals to 2ln2 minus a third minus 2 odds of 1 minus a third, a half, right? So, no, not even 2 odds of, because I'm subbing in 2 odds of this, right? So it's just literally that. Let me write that neater. Yeah, so you get 2ln2 minus a third, let's expand this, right, plus a half minus 1. Ooh, getting this alternating sort of thing. But what's important is when you sort of get one step where there's no ln's and it's sort of doing this sort of alternating thing, then there's an ln, like 2ln, and then now let's do one more step, right? Let's just do real explore this. They want me to sub this guy into here now, right? Just to really explore. So that was my answer for 3i and 2, right? And then 4i3 becomes 2ln2 minus a quarter, minus 3 lots of that, but this is 3 lots of that, so 2ln2 minus a third plus a half minus 1, right? You sort of slowly establish a pattern, right? So here, once again, that guy goes away, and you sort of get like, put the 1 first, so 1 minus a half plus a third minus a quarter. That's the answer for part 3. Yeah, so once I've done that, part 3 is done. But what's more important, and really what's leading me on to part 4, is show that generically that it equals to this guy for all odd and this guy for all even. And I can see it, right? I can see it here that when I subbed in, and just to be clear, this term here, you can see above here, that was when n equals to 3, right? This one here was when n equals to 2. So when I subbed in an odd number, no ln. You can see here, no ln. When I sub in an even number, 2ln, 2ln, right? So what I can say generically, right, is for part 4, so maybe I'll just move it up here. Right? I don't think I need that much space. So for part 4, for n plus 1 in, right now I know, using my recurrence of 2ln2 minus 1 on n plus 1 minus in minus 1, right? Yeah, so generically speaking, I can actually keep proving this where when n is odd, right? I want to know what my last term is, right? So basically, the numbers are going to keep going down, right? It's going to keep dialing down. Every time I sub in a recurrence, right, this will keep going down. What's my last term? Does it have ln or not, right? So let's see. When n is odd, so what's the lowest number it can be odd? In this case, the lowest number it can be odd is, let's see, n equals to 1. Is that right? Let me just check. Yeah, so the last term, actually, can I explore something, right? Let me sub in, just like I did in the first question. I'm just going to sub in one lot of this guy, right? One lot of this guy. So then this becomes 2ln2 minus 1 on n plus 1 minus n, or not even minus n. So next one down, say when n minus 1, so it'll be 2ln2 minus 1 on n minus n plus minus 1 I n minus 2, right? And that goes on and so forth, right? So just to be clear, that's just me subbing it in. So it feels like every time I sub something in, that guy goes lower and lower and it alternates, right? You can see the next step down, the 2 tail ends cancel out. If I sub that back in, comes back, etc. Right? So when n is odd, right? The last term, yeah, the last term, when that's odd, like let's say when, like I can see here, right? Let's say in this case, when n is 3, right? In this case, The last term, when that's 3, will be 2. Yeah, the very last term, there will be 2i1. Yeah, 2i1. Now, I know 2i1. I found it upstairs, right? Where is it? There, this green thing here, right? That should equal to 1 minus a half. So, no log term, right? So when n is odd, there is no log term, and the last term is this. So I can conclude, therefore, when n is odd, n plus 1 in should start with positive 1, right? I can see it there, minus a half, and it goes all the way to this first term here, right? Because the two ln's cancel out, so it becomes minus 1 on n plus 1, right? So therefore, I've proven the first half. Now, I'm hoping that the theory sticks when n is even, right? Let's see. When n is even, so when that's even, the lowest number of this term here has to be 2, right? The last term is equal to, sorry, the last term is, I think right, is there, is, when n is 2, I2, so 1, it's just I0. And what is I0? Did I actually do that? I did, right? So it's 2 ln2, which equals to 2 ln2 minus 1. So this is important, because if that's the last term, therefore, when n is even, then n plus 1, the expression, the recurrence formula, starts off with 2 ln2 minus 1, and then everything else sort of alternates, right? Minus 1 and plus. So 1 is like 1 on 1, right? So plus 1 on 2, minus 1 on 3, plus ... all the way up until the last term, which used to be minus, right? Sorry, it still is minus. So the last term is always 1 minus 1, right? And if you factorized 2 ln2, if you factorize a negative out, you will get this expression here, which is 1 on 1 minus half plus a third plus, because it's a minus 1 on n plus 1. Yeah, and then you proved it. So I guess what I'm saying is, for this one, the last piece, you just got to look at the patterns, all right? When n is odd, the ln's count, the 2 ln goes away, right? This one here, no log term. When n is even, has log term, right? And therefore, our expression has a log term in there. Guys, that is a hard question. It's 7 marks in the North Sydney Boys past paper. Will it come back? Maybe, who knows? I thought I'd show you a video with 2 really hard, lengthy questions. Hopefully that's okay, guys. That's it for this topic. Next topic that I want to do, due to a few requests, is perms and combs or combinatorics. Guys, I'll see you there. If you like the video, give us a like, subscribe to the channel, and tell your friends. See you later.